Okay, I'm back. So we will continue to study the solutions of ordinary differential equations. So we have this concept of explicit solution and an implicit solution, but uh, before defining them, let us recall from calculus. So recall from calculus. So this is a recall. So we have this concept of explicit functions and implicit functions. So explicit functions and we have implicit functions. So explicit functions are functions that they are of the form, for example, y is equal to x squared. So we know what is the function explicitly. So we know, for example, y is equal to cosine x, y is equal to x squared sine x. These are all explicit functions. On the other hand, implicit functions, they are given in an equation. For example, so we don't know what is y explicitly. So y square, x square plus y square is equal to 1. So y is not given explicitly. Or for example, cosine xy plus sine square x is equal to 2. Here also y is given in an equation. So these are examples of implicit functions. So the functions are given implicitly. So if you check out the meaning of this words explicit and implicit, so check out the dictionary. I think you will understand clearly. So let us define explicit solution and implicit solution. Okay. So definition. What is an implicit solution? What is an if a solution of an nth order ordinary differential equation is in the form y is equal to f of x, then it is called an explicit solution. But if the solution is given in a relation let's say like f of xy is equal to 0 in such a relation, then it is called an implicit solution. So let me give an example. For example, y is equal to f of x is equal to 2e to the power minus 3x plus 4 e to the power x is an explicit. So this is an explicit solution. We know what is y exactly. So this is an explicit solution of which differential equation? This differential equation. Y double prime plus 2y prime minus 3y is equal to 0. And so I will give an exercise, show that this f of x satisfies the given differential equation. So the given differential equation y double prime plus 2y prime minus 3y is equal to 0. So it is actual. So I give you as an exercise, show that it is actually a solution. And let me give an example of a implicit solution. For example, x squared plus y squared equal to, or let's say minus 16 is equal to 0 is an implicit solution of the differential equation. Of the given differential equation. Okay, now I will talk about some problems that we will solve in this course. So which are called initial value problem or a boundary value problem. So we will define such problems, and in this course we will mostly solve initial value problems. So okay, let me define. Definition, initial value problem we write shortly as IVP. So consider an ordinary differential equation with, so there are some conditions given with one or more supplementary conditions, one or more supplementary conditions are given such that, so we want the solution of the given ordinary differential equation must satisfy which the solution must satisfy. Okay, I will give example, don't worry, it will be clear. So if all the conditions, if all the conditions relate to one value, of an independent variable, then the problem is called an initial value problem. And we shortly write as IVP. So and if the conditions relate to different values, then it is called a boundary value problem. So if the conditions relate to different values, then the problem is called a boundary value problem. A boundary value problem. Okay, maybe I will copy it to the next page. Great. So we have initial value problems and boundary value problems. We say that the conditions if the conditions relate to one value, then it is an initial value problem. If it relates to different values, then it is called a boundary value problem. So what do we mean by that? So for example, let me give an example. So we are given a differential equation. So given y double prime plus y is equal to 0 with these conditions. So we want y1 to be equal to 3 and y double prime 1 to be equal to minus 4. So these are the conditions. So these are the given conditions. And if you realize that the conditions are given at the same value, so with one value, so the value is 1 here. So where the conditions are given, I mean, this is, I think I would like to change the condition given, because when we say one value, it is not the number. Okay, let's say y0 because it is like we always need to give the value 1, so I don't want to be misunderstandable. Yeah, it is. Okay, let's say we have the conditions y0 is equal to 3, y prime 0 is equal to minus 4, given at one value, which is x is equal to 0. So this is an, so this, so this differential equation is an example of initial value problem. So given ODE is an example of an initial value problem. Okay, let me give an example for a boundary value problem. So let's have the same differential equations, but this time the conditions are we want y0 is equal to 1 and y is pi over 2 is equal to 5. Also we have two conditions, so conditions, but they are given at different values. So one of them is given at 0, one of them is given at pi over 2. So we have the conditions relate to different values. So x is equal to 0 and x is equal to pi over 2. So that's why it is an example of a boundary value problem. So where the conditions are given at two different values, so which are x is equal to 0 and x is equal to pi over 2. So that is why it is an example of a boundary problem. So this problem is an example of a boundary value problem. So or we shortly write as boundary value problem. But as I said, in this course, we will solve only initial value problems. So you are again lucky. So in this course, we will solve only initial value problems.